So this is going to be part one of a two-part video on functions. So we are going to start looking at functions. And as we begin to look at functions, they might seem a little easy to you because we've already talked about linear equations. So when we're looking at functions, this correlates to the 6.05 quiz that is on your plan for today. So we're looking at these two standards today, and our whole objective is to be able to write function equations using a verbal description of the function, and to write a function equation using a graph of the function. So some questions I want us to be thinking about today. How can you identify and represent functions? And what are some characteristics that you can use to describe functions? So let's go ahead and get started. Basic vocabulary. For this unit, the basic vocabulary that you need to know is what is a relation? And a relation is a set of one or more ordered pairs. All right? And an ordered pair is two numbers that can be written in a certain order, such as our x comma y format. You could write it in a table. We can also use an arrow diagram and a graph to show ordered pairs. So anytime you have one or more ordered pairs, you have created what's called a relation. And all of these relations have a domain and a range. A domain is the set of all input values. So our input values are x, and that is our domain. Our output value is all of our y's, and that is called the range. So again, our domain is our x values, and our range is our y values. So you can see here, domain is the x value in the ordered pair, and the range is the y value in the ordered pair. So what all this has to do with things. So I want us to find the domain and the range. So the domain is going to be green and the range is going to be red. And yes, I'm using Christmas colors here. So to find the domain and the range of the relationship, remember domain is those x values. So in my ordered pairs, so if -2, -4, that domain is -2. In 0, 3, that domain is 0. In 2, -4, that domain is 2. In 4, 1, that domain is 4. So that means now I can go ahead and circle my range values. So those are all my y values. So -4, 3, -4, and 1. So that's from ordered pairs. Well, when I look at an arrow diagram, one of your circles will be your x values, the other one will be y's. Those x values, all those x values are your domain, or your domains, and all these y values are your range. So we're looking at this input and output. So what are relations and functions? Well, we just talked about this. A relation is a set of one or more ordered pairs. So remember, we can represent that by ordered pairs, a table, or a graph. But the key that we need to focus on here is a function. And a function is a special kind of relation in which one input has only one output. So that means not all relations are functions, because to be a function, you can only have one input for every output. So only one input for every output. That is very important. So when is a relation a function? In order for a relation to be considered a function, Each member of the domain, my x value, must be paired with exactly one y. So basically what that means is your domain, your x value, can only have one y. So if you see two or more x's in the function, you have a problem. It's probably not a function. So I know all of you are feeling like this right now. Don't worry, it's going to make more sense in just a second. So ordered pairs. Ordered pairs are represented as this. Remember, we have our x values, we have our y values. So to find out if something is a function, I want you to ask yourself, is there more than one x value that is the same? If there isn't, then it's a function. And if there is, then it's not a function. So let's go ahead and take a look at examples. So I want you to pause right here. Which one is a function? All right, so hopefully you had some time to think that over. Which one is a function? Is there more than one x value that is the same? And that answer is no. There's not more than one x value that's the same. Remember, those domains here, my x values are 4, 7, and 5. So no, those are not the same, which means this is a function. Over here in the second one, is there more than one x value that's the same? Well, my x values are 8, 9, and 8. So yes, there is, which means this is not a function because I have repeating x values. Hopefully you did okay on those. So let's try some more. So go ahead and pause again and let me know which ones are functions and which ones are not a function. All right, so let's go ahead and take a look at this first one. We have 4, 3, and 3, which means this is not a function because I have repeating x values. I have 5, 4, and 6, so yes, this one is a function. And 7, 4, and 3, so yes, this is also a function. Are you feeling better yet? All right, so let's go ahead and look at a table. Remember, when we look at tables, we can represent ordered pairs in columns. So I can put into columns my x's and my y's. So here's that 8 and that 3. So hopefully remember that we can represent ordered pairs in a table by taking our x values and placing them in one column. So my x values are 3, 4, 5, 6, and 7, and placing their corresponding y values, so 8, 8, 9, 9, and 10, into the y column. And we can use a table to determine if there's a function. So remember, we're looking for any double x's, all right? So if you look in this column, this x column, I have 3, 4, 5, 6, and 7. So there's no repeating x values. So because of that, this is a function. I want you to pause here and look at this table. Would this be a function? All right, so hopefully you said no. And the reason you would want to say no is because there's repeating x values. I have an input that has two different outputs. 4 goes to 6 and 4 also goes to 9. So that cannot be a function. Another way to represent these functions are a mapping diagram, or sometimes they're called arrow diagrams. So these tables are represented like this, where they have this arrow that maps a number to another number. And the ordered pairs you get from wherever the arrows are pointing. So the 1 in this column here is pointing to the 1 here, so that's my first ordered pair. The 2 is pointing to the 2, so that's my second. The 3 is pointing to the 3, so that's my third ordered pair. And lastly, that 4 is pointing to that 4, so that is my final ordered pair. And you can see that this would be a function because I have no repeating x values. So which one is a function? I want you to go ahead and take a look at these, and we'll come back in just a second with some answers. All right, so which one is a function? The one on the left is a function because every x has exactly one y. The left-hand side is not a function because 2 has 2 different y values. So I would write this as 210 and 220. Those are 2 separate ordered pairs, and that repeating 2 tells me it is not a function. Very good. So the vertical line test, and this is going to be the very last piece of what we look at in part 1. The vertical line test helps us to determine whether a graph is a function or not. You can literally draw a vertical line anywhere on the graph so that it hits the graph. If you draw this line and it hits the graph in more than one spot, the graph is not a function. So I'm going to show you what that means. If I draw a vertical line anywhere on this graph, it only hits it in one spot. So no matter what line I draw, it only hits it in one spot. If I were to draw a vertical line on this graph, if I were to draw a vertical line on this graph, and let me insert a line tool here, it hits it in 2 places. It actually hits it in 2 places, so one here, one here. So this would not be a function. So that vertical line test helps us determine if it's a function or not. So again, if it hits it in one place, it is a function. If it hits it in 2, it is not a function. So I encourage you to go ahead and pause right here and determine which ones are a function or not. All right, so let's go ahead and wrap up part 1 and let's check this out. So this circle here, if I were to draw a line through the circle, it would actually hit it in 2 places. It would be hitting it right here and right here. So this would not be a function. What about this U? And you're going to learn a name for this graph in algebra. If I draw a line, it only hits this graph in one place. So yes, this is a function. You have to be very, very, very careful on this last one. So if I draw my vertical line here, I'm going to make this a little bit bigger just so we can see. If I draw that vertical line there, it is a function. But what if I move this vertical line here? Well, then it's no longer a function because it's now hitting it in 2 places. So this last one, hopefully you saw that they do overlap in one area. So this would be not a function. All right, so that is all for part 1. We did it. Yay! You guys got this. All right, so make sure you check out part 2 so that way you are fully prepared for that 6.05 quiz. Thank you so much for watching.